Okay, so now let's get into this same problem, but with a different initial concentration of H2SO4. Okay, so it's going to be the same scenario where we put H2SO4 in solution, and as a strong acid for its first proton, it's going to pop off that first proton, and we know that the concentration, I'm just going to write it directly. We know this H plus concentration is going to be 0.001 molar, and we know that the bisulfate concentration is going to be 0.0100 molar. That's because we know that the H2SO4 concentration was that molarity, and it dissociates completely to create those concentrations. Okay, so now let's go once again back through our Rice table. Okay, we're doing this with the bisulfate HSO4 minus, and it undergoes its weak acid equilibria to make H plus and let's see, SO4 2 minus. Okay, let's write that again so it's a little bit less sloppy. Okay, SO4 2 minus. All right, and then now we can see that we've got a new set of initial concentrations. So my HSO4 is the 0.01 molar. My H plus is the 0.01 molar, and sulfate is still 0. Okay, so that means that it also has to be plus X. The H plus has to be plus X. The bisulfate has to be minus X. And now maybe what you can see here is the 5% rule is not going to work out for this problem. And now it's not going to work out anymore because we still have the same Ka value at 1.2 times 10 minus 2, right? But our initial concentration is 0.01 molar. So hopefully you can see that's pretty obvious that it's not going to work out. When the Ka value and the initial concentration are like, roughly the same, number, 5% rule is not going to work. Okay. So now we've got to leave everything as is. And I'll go ahead and set that up here. So we can now say Ka 1.2 times 10 minus 2 equals, and once again, that's H plus times sulfate divided by bisulfate. So now that's going to be 0.0100 plus X all times X, and then divided by 0.0100 minus X. And then with this problem, we will definitely end up with a quadratic equation. I'm going to skip a few steps because I want you guys to practice this algebra on your own. I want you to try and get to the correct answer without the instructor assist, okay? So I'm just going to give you what the solution should be, and you should definitely work this out to see if you get the same answer that I do, okay? So we'll say solve using the quadratic formula, right? And when you do that, we get X to equal, I get X to equal 4.5 times 10 to the negative 3. Okay, so now what does that mean for our concentration? Are we ready to use that for H plus concentration? Well, we're not, because remember, our H plus was the 0.01 molar from that first proton plus X, okay? So now that means H plus equals 0.0100 plus that number, and I'll change it to decimal form just so that we can get our sig figs right, okay? So we know that when we're adding numbers together, it's all about the last decimal point. So here this number is 1, 2, 3, 4 is the last decimal point, and 1, 2, 3, 4. Okay, beautiful. So now we can just call that 0.0145 molar. And then, of course, it's going to be the negative log of that number for the pH. So pH equals the negative log of 0.0145. Okay, lovely. And let's go ahead and calculate that. So 0.0145 log. And then now check it out. We have 1, 2, 3 significant digits in the log. So we're going to have 1, 2, 3 decimal places. Once again, remember the negative and the negative cancel. So we can say that pH equals 1.839. Okay, great. So once again, prove to yourself that you can get to that x equals 4.5 times 10 to the minus 3, all right? And then you should get this 1.839 for this pH. Okay, folks, hasta luego.